Hello and welcome to a new video and start of a new journey in our continued quest of trying to master geometry. And our today's agenda for the next few sessions is going to be similarities. So hopefully by now we have already mastered congruence and we not only understand the rules of congruence, we have also seen that it works like a tool for us in deriving so many other theorems, from triangles up to circles, properties of chords. All of these we derived using the idea of congruence. So it is a very important tool for us. Similarly, another very important tool for us is going to be the idea of similarity. What are the properties of similar triangles and what is the criteria for two triangles being similar? Because once again, if I can conclude that two triangles are similar to each other, a lot of other information opens up for me and I can use those results to solve problems or derive even more theorems. So that is going to be our agenda to master similarities. But before we begin with similarities, we'll start with an even simpler idea known as a basic proportionality theorem. So let's get started with that first. So what is the basic proportionality theorem? That if there is a triangle ABC and I draw a line DE parallel to one of the sides BC. So the information given to me is that DE is parallel to BC. This line will divide the sides AB and AC, the other two sides, in the same ratio. That means the ratio of AD is to DB is going to be the same as the ratio of AE to EC. That means, say for example, and this is just to get familiar with the idea, if this is 1 units and this is 3 units, the ratio is 1:3. The ratio of AE and EC is also going to be 1:3. And remember, I'm not saying that if this is 1 units, this is going to be 1 units. I'm saying if this ratio is 1:3, this ratio is also going to be 1:3. To be even more clear, right, this is 1x, 3x, and this would be 1y and 3y. Because in this case, it might look like these two parts are equal. So let me draw another triangle where the third side is very, very long, so that I can see the idea in action. And I draw a line parallel. And let's say the ratio of these two parts is 1:4. The ratio of these two parts is also going to be 1:4. So in this case, there might be a chance of confusion, but in this case, I can see this side is obviously way bigger than this side, right? That means if there is a line parallel to one side, it will divide the other two sides in the same ratio. To be even more specific, AD upon DB is going to be equal to AE upon EC. I can very quickly give you a problem also. I tell you this is 1.5 centimeters, this is 3 centimeters. You know this is 2 centimeters. How much is this going to be? So you can see here the ratio that the line DE divides the side AB in is 1.5:3 or 1:2. Same ratio is going to work here, 1:2. This is already 2, that means this was going to be 1 centimeter. So this was obviously a very simple application, but before we get into the details and start using it to solve problems, and remember in geometry, if you know the idea, the problem solving is going to be very, very easy if you are familiar with the idea. Otherwise it might be next to impossible because you might not be able to think at all what tools to use, right? So we got the result, but first of all, before mastering the application, we want to question this result itself and prove where did this come from. Because that process of proving itself is going to do wonders for you. It will improve your comprehension of these basic similarities, connection between figures. It will improve your problem solving skills, and most importantly, it will improve your why asking, and which is the fundamentals of problem solving. You ask a why and the problem solving becomes easier for you, right? Because essentially a why is asking the logic. So you're constantly working with logic. So let's figure out why this result is working for us. So first let me make the triangle a little bigger so that it's easier to study. A, B, C and a line drawn parallel D, E. So given information, DE is parallel to BC, and I wanted to prove that AD upon DB is equal to AE upon EC. So this will take a few steps, but the first time it might look very unfamiliar, but do it a couple of times and the idea would be visible to you very, very clearly. So I want to reach here, and this is the information given to me, plus I have all the tools, whatever tools I have picked up earlier, right? So let me start working on this. The first thing that I'll do is I'll draw a perpendicular from E on AD, and let's say call it N. Perpendicular means this is going to be 90 degrees. And also if I think of triangle ADE, EN is going to be the height for it, right? This is the base and this is the height. If you want to draw it again, especially for beginners, this is the base AD, AD is the base, and this E was the vertex here, and you're drawing a perpendicular, so this is the height of the triangle. So if I think of triangle ADE, there will be more figures, but I'm going step by step, so the process is very clear to us. If I think of triangle ADE, area of triangle ADE, what is the area of a triangle? Area of a triangle is half into base into height. This idea again we have worked out, derived, proved, so we know the area of a triangle is going to be half base into height. So just a couple of pointers. So you can obviously have this as the base and this as the height, but sometimes the altitude might lie outside of the triangle. There should not be a problem at all. So this would be the base and this would be the height that you would consider. So just a couple of ideas to get started with before we start working on this. So the area of triangle ADB is going to be base, AD is the base, and EN is the height. Is going to be half, AD is the base, AD into EN. So before we go any further, write this result down for yourself because you'll be using it later. Let me create another story. Let me connect B and E. And now I'm thinking of triangle BDE. Triangle BDE. If you think of triangle BDE and if you rotate your point of view and consider BD as the base, once again EN is the height of the triangle BDE. How? If you want to draw this again for yourself, put B here, D here, and something like this. This E is here, and you can see that EN, the perpendicular, is the height of this triangle. So EN is the height of the triangle BDE, because remember the height can fall outside the triangle also. That should not be too much of a problem. And in case you're not familiar with the idea, now you're learning. This is the base and this is the height. The first time that you look at it, it might be very, very difficult, but repeat the process a couple of times and hopefully with time the process will get better and better. So triangle ADE, the base was AD and the height was EN. For triangle BDE, the base is BD and the height is EN. So let me write down triangle BDE is equal to half DB into EN. And for now, let me think of the ratio of the areas of the triangle ADE and the triangle BDE. And if I want to create a ratio numerator by denominator, this half gets cancelled. This EN is also getting cancelled. So I'm left with AD upon DB. So once again, let me just stay with the final result and you can write it down for yourself somewhere. AD upon DB. So AD upon DB. So I'm heading somewhere here. I have maybe halfway through. Now maybe forget this line altogether and draw another perpendicular from D to the side AE and call it M. So now this is the perpendicular. Now think of the same triangle ADE. AE is the base and DM is the height. AE is the base. I'll not draw this again. Tilt your head and watch it like that. AE is the base and DM is the height. So once again, if I look at area of triangle ADE, is going to be half AE as the base and DM as the height. So another result for you. Now I will join D to C, and now I look at triangle DEC and think of EC as the base. If I think of this triangle, isn't this the height for triangle DEC? Stop, hit pause, maybe draw it out for yourself in the orientation that you're comfortable with. I'm saying this is the base and this is the height for the triangle DEC. Same idea as earlier. So once I get that, I have area of triangle DEC is equal to half of, I have EC as the base and once again DM as the height. So actually the same idea that you worked out earlier, repeating once again. So going from here to here also, your speed should pick up, and your visualization should improve. So this half gets cancelled again, this dm gets cancelled again. I'm left with AE upon EC. I'm left with AE upon EC. So I've got the two paths. How do I connect them together now? To do that, we will use another idea that we picked up in our journey, and the idea was that if I have two parallel lines and there are triangles between these two parallel lines with the same base, the area of these two triangles are going to be equal. Area of triangles between the same parallel lines having the same base is equal. Another idea that we have worked out in quite a lot of detail. So I should already be familiar with this idea and being applied here, so it's getting revised also. DEC and triangle BED, both of them are between the lines DE and BC. That means they are between the same parallel lines. And if you think about it, for both of them, this DE is the base or the common base. Just change your orientation again. Think of this as the base. DEC is one triangle, and think of this as the base. DEB is another triangle. So this is the common base. These two triangles are between two parallel lines, the same parallel lines, and have a common base. That means their area is going to be equal. That means area of triangle BDE is equal to area of triangle DEC. And what is the theorem behind it? Triangles between the same parallels having the same base have equal area. So I know these two triangles are equal to each other. Now notice this result. This was triangle ADE upon triangle BDE. This one was area of triangle ADE upon area of triangle DEC. We have already worked out the values, but instead of DEC, area of triangle DEC, can I not write area of triangle BDE? So I can write area of triangle BDE. So this is area of triangle ADE upon area of triangle BD. This is also area of triangle ADE upon triangle of BD. That means these two are going to be equal to each other, and I finally reached the last step. AD upon DB is equal to AE upon EC. So now you can surely say, when you draw a line parallel to one side, it will divide the other two sides in the same ratio, because the ratio of AD upon DB is going to be the same as AE upon EC. Why? You have just proved why.